In progress.
Good morning, this is your Stats Sensei, Mr. Spensei, and we're going to go through observations versus experiments, multiple choice. This is going to be a bit of a longer video, and I apologize for that. So, two studies are run to compare the experience of families living in high-rise public housing to those of families living in townhouse subsidized rentals. Well, that doesn't let us know anything about observation versus experiment. The first study interviews 25 families who have been. Okay, the fact that it says interviews lets me know that this first one is a study, is an observation, who have been in for at least 1 year, while the second randomly assigned. So here we have random assignment. As soon as we have random assignment, we have an experiment. So the first is an observational, the second is an experiment. So the first study is an observational, while the second is an experiment. That is 1C. All right, moving on. Two studies are run to determine the effects of low levels of wine consumption on cholesterol level. The first study measures the cholesterol level of 100 volunteers who were not permitted to have, okay, so we are assigning them something. We're not permitted to have consumed wine for a year and then compare these values with their cholesterol after 1 year. So this first one is an experiment because they were not allowed to, and then we compared it after a year, so they were assigned not to do that. The second study measures the cholesterol levels of 100 volunteers who have not consumed alcohol for the year and randomly picks half. So once again, we are assigning. All right. So both of these are experiment. So both studies are experiments is letter E. And once again, this first one is they are being compared to themselves. In 1992, a London study, 12 out of 20 migraine sufferers were given chocolate whose flavor was masked by peppermint, while the remaining 8 sufferers received a similar tasting tablet that had no chocolate. All right, so it says we're given. I like the word assigned, but that still lets me know that treatment was imposed, so this is an experiment. All right, with 1 day, 5 of those receiving chocolate complained of migraines. Um, while no complaints were made by any of those who did not receive chocolate. Which of the following is true? This was an observational study. That's not true. This study was a sample survey. No. A census means we surveyed the entire population. A study was performed using it as a placebo. Nope. The chocolate is not a placebo. The chocolate is the treatment. And so this is E. An experiment was performed comparing a treatment that was given chocolate to a control group that was not. The placebo was the group that was not given chocolate. All right, moving on to number 4. Suppose you wish to compare the average class size of mathematics to average class size of English classes in your school. Which is most appropriate? Well, in this case, we could actually survey um, every math class and every English class. And consequently, since we're surveying all, that would make it a census. Which of the following are true statements? Based on careful use of control groups, experiments can often indicate cause and effect. Yes, experiments can do that. That's a true. While observational studies may suggest relationships, great care must be taken in concluding that there is a cause and effect. Basically, they're saying they should not show cause and effect. That's true. Observational studies show relationships, but not cause and effect. A complete census is the only way to establish that is false. Experiments are the only way. So our answer is we have 2 truths. So our answer is A, 1 and 2 only. Which of the following are true statements? In an experiment, researchers randomly assign people to different treatment groups. That's true. In an observation study, the participants select the group they are in. Yes, we're watching them, we're observing them do what they already do. That's true. A control group is most often a self-selected group in an experiment. That's false. Once again, we assign them to those groups. So in this case, our answer is again A. It's 1 and 2. In one study on the effect of niacin on cholesterol, 100 subjects who acknowledged being longtime niacin takers had their cholesterol levels compared with those who had not. All right, they're already doing this on their own. That makes this first one an observational. So our first one's observational because they already are doing this on their own. In a second study, 50 subjects were randomly chosen. Oh, they were assigned. As soon as I see random, I know that uh, they were assigned, so that makes it an experiment. The first study was an observation, and the study was a controlled experiment. The answer is B. Number 8. In one study, subjects were randomly given either 500 or 1,000 milligrams of vitamin C daily. Ooh, given. That means they were assigned. As soon as I see that, I know that this is an experiment. So this first one is an experiment. In a second study, people responded to a questionnaire. Oh, this is a survey. So that makes it an observational study. The first study was an experiment, while the second was an observational study. Looks like A to me. Which of the following are true statements? In an experiment, some treatment is randomly assigned to the groups. That's true. In an observation study, information is gathered on an already existing situation. That is also true. We're observing them do what they already do. Sample surveys are observational studies, not experiments. Yes, surveys are observational studies because no treatment was assigned. They're reporting on what they are already doing. So which are true? 1, 2, and 3. 10. A study is made to determine whether studying Latin helps students achieve higher scores on the verbal section of the SAT exam. In comparing records, we're comparing records. This makes an observation studies, half of whom have taken at least 1 year. It is noted that the average SAT verbal score is higher than for those students who have taken Latin more than from those who have not. Based on the study, guidance counselors begin to recommend Latin for students who want to do well on the SAT. Which answer is wrong? So this is an observational study. While the study indicates a relation, it does not prove causation. That's true. And remember, we're looking for what is wrong. There could be a confounding variable responsible for the seeming relationship. Anytime you're running an observational study, there could be a confounding variable. In this case, we have students studying Latin. That's probably the smarter student. Well, aren't smarter students going to have higher SAT scores? So intelligence could be a confounding variable. It's causing us to not know whether or not it's studying Latin or intelligence that's causing the changes that we're seeing. Self-selection here makes drawing the counselor's conclusion difficult. Self-selection is what happens on every observational study, which means we can't tell if it's an experiment. This is an observational study. I mean, the self-selection means we can't tell, we can't say causation. This is an observational study. Yes, we've already said that because they weren't assigned. So none of the answers are incorrect. So the answer is E. All right. Number 11, consider the following studies being run for 3 different nursing home studies. One nursing home has pets brought in for an hour every day to see if the patient's morale is improved. All right. One nursing home allows hourly visits every day for kindergarten students to see if the morale is improved. One nursing home administers antidepressants to see if the patient's morale is improved. All right, there was no random assignment. We are doing this to all of these. So none of these studies uses randomization. That's true. None of these studies use a control group. Nope, none of them did. Everyone got all the treatments. None of these studies uses blinding. Yeah, we definitely know that they know whether they got visited by a dog or people, um, or whether they got medicine. Important information can be obtained from all of these studies, but none will be able to establish a causal relationship. That's true because none of them are experiments. So once again, number 11, all of the above, all of these are true. Number 12, in a 1927 and 1932 Western Electric Company on the effect of lighting on worker productivity, productivity increased with each increase in lighting, but also then increased with every decrease in lighting. So basically, it was changing regardless. So consequently, the change in lighting is a placebo. This is the placebo effect. all right, where they believed it was doing something when in fact it wasn't. It had nothing to do with worker productivity. The placebo effect is saying that, hey, we got a good result, even though it really didn't have an impact. The lighting didn't impact, and the reason we know it didn't impact is because it went up it went up when we increased the lighting, and it went up when we decreased the lighting. So obviously, lighting didn't have a real impact. When the estrogen blocking drug tamoxifen was first introduced to treat breast cancer, there was concern that it would cause osteoporosis as a side effect. To test this concern, cancer subjects were randomly selected and given tamoxifen, and then their bone density was measured before and after the treatment, which is the following um, is a true statement. Okay, in this case, they were measured twice. All right. So this was a study in which the subjects were used as their own controls because they were measured twice. They were measured before and after the treatment. I know that's tricky, and this is letter C. It is an experiment because they were randomly chosen and then they were measured before and after. So they're checking bone density twice. Which of the following is incorrect? Blocking is to experimental design and stratification is to sampling design. That is true. We're breaking into groups based on a common characteristic. The next one, by controlling certain variables, blocking can make conclusion more specific. Yes, we are definitely controlling variables. We're saying, hey, the females may react differently than males. People may react differently because of their ages. The paired comparison is a special case of design of blocking. That is true. A match pair design is a special case where you act as your own block. Blocking results in decreased error because the blocks have smaller size. Wrong. All right, that's false. That's not why. In a randomized block design, the randomization occurs within the blocks. That's true. So the only one that's false is D. That's our answer. Is hot oatmeal with fruit or Western omelet with home fries a more satisfying breakfast? 50 volunteers are randomly divided into two groups. One group is fed oatmeal. Oh, we randomly divide them and we gave them some. So this is an experiment. Each volunteer then rates his or breakfast on 1 or 2 scale satisfaction. On a 1 to 10 scale for satisfaction. If the Western omelet with home fries receives a substantially higher average, what is a reasonable conclusion? And the answer is treatments were assigned. In general, people find Western omelets home fries more satisfactory than hot oatmeal. Well, that sounds pretty good. So we'll say that's there. There's no reasonable conclusion because the subjects were volunteering. Nope, that always happens for experiments. There's no reasonable because of the small size. Not 50 is large enough. There's no reasonable conclusion because blinding was not used. Don't have to use blinding. It's nice, but don't have to. There is no reasonable conclusion because there are too many confounding variables. Nope, this is still an experiment. We still assigned them to eat one or the other. All right. Which of the following is a true statement? In well-designed observational studies, responses are systematically influenced during the collection. False. That's not true for an observational study. In well-designed experiments, the treatments result in responses that are similar as possible. False. They might, but they don't have to. A well-designed experiment randomly assigns treatments. That is a true statement. Causation and association are unrelated. No, they are very related. That's false. They are causation and association are unrelated because causation means this causes that. Association means this could happen. So this is false. In a well-designed, well-conducted experiment, strong correlation means that there is a cause and effect. Strong correlation association means there is a cause and effect. Well, this goes back to that. D, this isn't really the best question, but well-designed experiments randomly assigns treatment. That's definitely the best answer. So while E is somewhat true, it's not the best answer. The best answer is letter C, because that's what assigns. In a well-designed, well-conducted experiment, strong correlation indicates that there might be a cause relationship, but it doesn't prove it. I don't like that answer, so we're just going to ignore that. The best answer is for 16 is C. Number 17, which of the following is not important in the design of experiments? Control of account control. Yes, control is very important. That's a true. That's important. Randomization is assigning subjects to different treatments. That's true. We got to do that. Replication of the experiment using sufficient numbers of subjects. That's true. Care and observing without imposing treatments. No, we have to do that. Isolating variable by creating homogeneous block. Um, all of these have a element of truth. Um, but this is the least good. I need to get rid of this one. All right, but this is the least one because we do isolate variable by creating uh, um, blocks. Which of the following is a true statement about the design of a matched paired experiment? Each subject might receive both treatments. That's true. Matched paired, they both receive. Each pair of subjects receives the identical treatment and different in their responses are noted. That's pretty well true. Blocking is one form of a matched pair design. Oh, each pair receives identical. That's false. Each individual, the individual receives the treatment. Um, Blocking is one form of match paired. That's false. It's the other way. Match paired is a form of blocking. Stratification, we don't stratify for experiments. That's false. Randomization is necessary, unnecessary. No, randomization is always necessary. So each subject might receive both treatments. 18 is A. That's our best answer. 19. Some researchers believe that too much iron in the blood can raise the level of cholesterol. Um, The iron level in the blood can be lowered by making periodic blood donation. A study is performed by randomly selecting half of a group of volunteers and assigning them to give periodic blood while the rest do not. Is this an experiment or observational study? Well, the key word is assigning. All right. So this is an experiment. So first off, that gets rid of D and E because those are observational studies. It doesn't mention anything about dividing them into groups, so no blocking. They're giving blood, so they're probably not blinded. And in this case, we can say it's a single variable because they either give blood or do not. So we have random assignment. We're going to compare results. We're going to compare cholesterol levels, and they either give blood or no blood. So in this case, I only have one variable. So 19 is A. 20. Do teenagers prefer sports drinks colored blue or green? Two different colorings which have no effect on taste are used on the identical drink to result in a blue or green beverage. All right. Teenagers are randomly assigned, so this is an experiment. And then the volunteers then rate the beverage on 1 of 10 scale. Because of the concern that the sports drinks interest may affect the outcome, the volunteers are first blocked by whether or not they play on a high school team. Is blinding possible in this experiment? So, um, all right. So in this case, Is blinding possible? Well, the experimenter might be blinded, but the person drinking it would not be blinding. So the volunteers know this is because the volunteers know which treatment they're receiving and they know whether they're drinking blue or green. They definitely going to see that. So that's a true statement. That's false. That is blocking. We don't care about that. Yes, by having the experiment in a separate room, randomly pick one of the two containers and remotely um, have a drink poured from that container. E. Um, that doesn't tell me anything. That doesn't work. Yes, by having statistician analyzing the results, not know which volunteer sampled which drink. That's true. So we can have blocking, all right, by having the statistician not knowing which volunteer sampled which drink. All right. The volunteer will know, but the statistician does not have to know. So our answer choice on this one is D. The statistician would not have to know. All right. Well, I appreciate you watching. I hope this helped a little bit. I know some of these were a little bit confusing, and I'll make sure they're not like that on the test. Hope to see you on the next one, and thank you.